Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing inequalities. This is standard A.3D in the great state of Texas, and we are using item number 41 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got this basic inequality here. I'm going to rewrite it over here so I can see it while I am scrolling. X plus 2y is greater than or equal to 2. Now, if we know what this means, we can solve this problem in about 4 seconds, because if you take a look, each line is actually identical in regards to its slope, right? It's passing from 0, 1 down to this 2, 0, right? And so we've got this slope of -1 over 2. So its slope is -1/2. And it's the same thing for each of ours, right? So if we were to just scroll this up, we could see that same slope in all of our problems there. So that's not really the issue. Identifying the slope is not really the issue. What we see here is I've got lines that are both dotted and solid, and then the shading is either above or below. That's the question. So is it dotted or solid? Or is the shading above or the shading below? Well, if we don't recognize this inequality and what it tells us, there's a way to test it. So let's just take one of these points. Okay, so let's take the y-intercept here. All right, so I'm going to take this y-intercept of x is 0, and then y is 1. So I want to plug this in, and I want to see if I get a true statement here. Okay, can I include a number on the line? That's my first question. All right, so I'm going to rewrite this as x is 0 plus 2 times 1 greater than or equal to 2. So that's just 2 is greater than or equal to 2. So that is correct, which means I am going to use the numbers on the line. Now, what that means is my dotted line is either going to be greater than or less than. So you don't include the numbers on the line. We just proved that you can include the numbers on the line, and it works into a true statement, which means I need a solid line, because that is going to be greater than or equal to or less than or equal to. So it needs to be solid. So if we were to look at these, I can eliminate B and I can eliminate D. Now the question is the shading represents the rest of the solution set. Is it above or below? Well, we can get pretty simple here. Let's just pick a point above and a point below. So a point below, right, if I'm looking at C possibly, let's just go super easy. Origin, okay? So I'm going to rewrite this, but I'm going to have x and y equal 0. So 0 plus 2 times 0 greater than or equal to 2. That just cancels out. So it's 0 is greater than or equal to 2. Does not work, so I can't use this here. So I'm thinking it's going to end up being something above. Let's use something simple. Let's do a 3 and 3. All right. So we'll do x is 3 plus 2 times y is 3 greater than or equal to 2. So that's going to be 3 plus 6 is greater than or equal to 2. 9 is greater than or equal to 2. That is correct. So we know it needs to be a solid line. We know we need to shade above, right? So that C is not going to work because it shades below, grabs at 0, 0, which does not work. So we are left with A, and this is where this can turn into a 4-second problem. Since all of the lines are exactly the same, if you know this particular symbol that's greater than or equal to, greater than means it's going to be above the line, and that equal to means it's going to be a solid line. You could have solved this by simply looking at the inequality, the greater than or equal to, and realize that you're going to shade above the line. It needs to be a solid line. And out of the 4, even before you calculate the slope, that's the only one that's got a solid line with a shading above. So that's our answer A.